All right, lesson 2 is about the Pythagorean theorem, and we're going to put two sections together from the book, which are the Pythagorean theorem, and then its converse. And remember, since the beginning of the year, we've been taking converses and making them biconditional statements. So we've taken the Pythagorean theorem and made it a biconditional statement. So first of all, what is the Pythagorean theorem? Well, again, it's very important that you remember it's related to right triangles, but you probably won't forget that because this whole entire unit is about right triangles. But you need to understand the converse and the Pythagorean theorem, and then see how it's related to obtuse and acute triangles as well. So the Pythagorean theorem is one of the best known and most useful theorems in all of mathematics. The theorem will eventually be used to do right triangle trigonometry and to calculate dimensions for finding areas and volumes. So what is the Pythagorean theorem? Well, some of you might have learned it in terms of the letters A, B, and C. So if I make a right triangle, we usually call the two legs A and B, and then the hypotenuse is letter C. So again, it's very important that you know the hypotenuse is the longest side of a right triangle. So the Pythagorean theorem says a squared plus b squared equals c squared. So if we literally drew a square out here, and we took this area and added it to the area of this square with b by b dimensions, it should equal the area of this square. And you might have learned that in middle school, and you might have cut out, this square and put them in this one. And that's fine. Or you can look online and read more about it. But we're just going to go through and learn how to apply the Pythagorean theorem. So what is the actual Pythagorean biconditional say? Well, it doesn't say a squared plus b squared equals c squared, right? So you have to look at what it says. It says, a triangle is right if and only if the sum of the squares of two sides, so here's the sum of the squares of two sides, is equal to the square of the third side. And the third side has to be the hypotenuse. So the sum of the squares of the two legs of a right triangle must equal the hypotenuse squared. So it's biconditional, which means if I know this is a right triangle, then that should be true. Or if I give you a triangle and I say this is 3, this is 4, this is 5, oops, and that right angle shouldn't be in here. And I said, is this a right triangle? Well, the converse says that if 3 squared plus 4 squared equals 5 squared, then it is a right triangle. But then the original is, if you have a right triangle, then a squared plus b squared should equal c squared. All right, so let's go ahead and try some of these practice problems. You could pause now and do some on your own, then check your answers with me, or you can just go along with me if you want to. So this first one, it's a coordinate system here. Well, let's read the directions, I guess. It says, use the Pythagorean theorem to solve the following problems. Leave your answers in radical form. In other words, no decimals allowed. Your answer must be exact. So if you get square root of 2 as part of your answer, don't push and get a decimal answer with that. Just leave it as square root of 2. Okay, so here, this first one is in a coordinate system. And this point right here is 5, 12. So we have to find r. Well, what is r? R is the radius of this circle. This point here is the origin, so it's 0, 0. So we're trying to find the length of r. Well, if you start at the origin, this ordered pair tells us we're going to go right 5 units, and then we're going to go up 12 units. And when you go right 5 and up 12, what do we create right here? Well, hopefully you're saying to yourself, we created a right triangle. And that right triangle now has a side length of 5, a side length of 12, and we're trying to find r. Well, what is r in this right triangle? It is a hypotenuse. So we use the Pythagorean theorem that says if we take one leg and square it, and add it to a second leg and square it, it should equal the hypotenuse squared, which is r in this case. So 5 squared is 25, 12 squared is 144. So we add those together, we get 169 equals r squared. We take the square root of both sides, so what does r equal? R equals 13. And how do I know it's positive 13? Because right here, technically, you should be putting plus and minus 13 because negative 13 squared is also 169, and positive 13 squared is a positive 169. But the negative doesn't work. How do I know that? Because I went to the right and then I went up. So this has to be a positive length. Or you can say to yourself, actually, that has nothing to do with it, sorry. It's just that it's the radius of a circle. And can you ever have a negative length for the radius of a circle? No, you cannot. So that answer will always be positive. Okay, let's look at number 2. Find the amount of fencing needed for the perimeter of a rectangular lot with a diagonal length 39 meters and a side length 36 meters. So we have a rectangular lot, we have a diagonal of length 39 meters and a side length of 36. So obviously a rectangle, we learned about quadrilaterals. What do we know about a rectangle? We know that all 4 angles are right. So then we have a right triangle right here. We're trying to find the perimeter. So in order to find the perimeter, we need to find the other length. So we have 36 squared, which is one leg of a right triangle, plus x squared equals 39 squared. So go ahead and do the math. Once you solve for x, then you can find the perimeter by plugging it back in. So I have to use my calculator. So 36 squared is 1,296. 39 squared is 1,521. So we subtract 1,296 from both sides. I get x squared equals 225. Therefore, what does x equal? Remember, you take the square root of both sides. So x equals 15. So therefore, what is the perimeter? So that's not my final answer. My final answer is I have to add 15 plus 36 plus 15 plus 36, right? So that's 72 plus 30, which is 102 meters. Okay, number 3, the congruent sides of an isosceles triangle measure 6 centimeters. So the congruent sides of an isosceles triangle. So that means that we have each of these side lengths here are 6 and 6. And the base measures 8 centimeters. Find the altitude. So the altitude comes down from the vertex angle, and what does an altitude do? Well, it intersects the opposite side as in a right angle. Now remember, if it's isosceles, not only does it intersect at a right angle, it bisects the base. So now I know this segment is 4 and this segment is 4. I'm trying to find the length of the altitude. So again, hopefully you can see your right triangle right here. We have a length of 4 for a leg, a length of x as a leg, and 6 is the hypotenuse. It's opposite the right angle. So I have 4 squared plus x squared equals 6 squared. 6 squared is 36. 4 squared is 16. I subtract 16 from both sides. I get x squared equals 20. So now I can say x equals the square root of 20, or if you have a TI Inspire calculator, it's going to tell you that x equals 2 root 5. Either of these answers is fine. I just don't want a decimal. So leave it as square root of 20 or leave it as 2 root 5. Let's do number 4, and then the second video will show you the rest of the problems on the second page. How high on a building will a 15-foot ladder touch if the foot of the ladder is 5 feet from the building? Okay, so let's say this is the building right here. The ladder is coming out, right, like this. This is the ladder. So this is the ground. So it says the ladder is 5 feet from the building. So this is 5 feet from the building. And obviously my drawing might not be very good, not drawn to scale. Here's my right angle right here. The ladder is 15 feet. This time I gave you the hypotenuse, right? So now we have to set it up as 5 squared plus x squared equals 15 squared. This is the height. This is how high it's going to touch up there. So now I do 15 squared. Well, I know from above that 15 squared is 225, right, from this example up here. So I subtract 25 from both sides, and I get x squared equals 200. I take the square root of both sides, so I can leave my answer as the square root of 200 feet. Sorry, I should have put centimeters here. Square root of 200 feet, or if you have your TI calculator, TI Inspire, the TI 84s won't do this, so TI Inspire will give you 10 root 2. So that is how high up the building the the height of the ladder will touch. Next video for the rest of the back of the page. Oh, sorry. I guess I still have more time now, so we don't need to go to the next video. So again, if you have questions, ask the substitute. They might be able to help you, or ask a different math teacher during one of those review sessions. Okay, otherwise we're going to keep plugging away here. Okay, number 5, a rectangular piece of cardboard fits snug on a diagonal in this box. What is the length of the diagonal of the cardboard rectangular piece? So they're asking us to find from upper corner down to lower corner. So if you look at our classroom, from the upper corner above my desk, down slicing through the classroom back to the corner by the door, right? That's what that diagonal they want you to find. So what do you know? You know this length here is 40, you know this length here is 60, and you know this height here is 20. Well, this 40 and this 60 combine with this diagonal here, and this is a right triangle. This 40 is a leg, this 60 is a leg, and this diagonal, it's like across the bottom of the floor, right from my desk back to the door, that's across the floor. Then it would be 40 squared plus 60 squared equals this across the floor diagonal x squared. So we have to square our 40, we have to square our 60, sorry I'm doing that with my calculator, I'm adding them together. So that's 1600 plus 3600 equals x squared. So x squared equals 5200. Okay, well now I'm going to take that and I'm going to create this right triangle. So this is the height, which is over here, which is 20, across the diagonal, which we know x squared equals 5200. And then we have the hypotenuse. So this is my right angle now. It's up the wall of the room, meets the floor at 90 degrees. So now I have 20 squared plus x squared equals the actual answer we're trying to find, which I'll call that y, equals y squared. Okay, well 20 squared is 400, x squared is just 5200. That's why I didn't take the square root before, because I knew I was going to go ahead and square it anyway. So x squared is 5200, so 400 plus 5200 is 5600. So now I take the square root of 5600, and what do you get? So, let me see. You can either leave it as 20 root 14, or you can leave it as a square root of 5600. Either one of those are fine, and then you should have centimeters attached to it. So what is the diagonal here? Y equals the square root of 5200 centimeters, or 20 root 14 centimeters. Oh, I love this next question. It's super tricky. It says, both quadrilaterals are squares. Find y. So this means this is a 15 by 15, right? And this is 25 centimeters squared. Well, if that's 25 centimeters squared for this area, the area of a box is just side x times x to get this area. So what do we do to both sides? We take the square root, so x equals 5. So now this is 5. Well, if we combine, this is 15, this is now what? Well, that's 15 plus 5, so this whole length is 20, and we're trying to find the diagonal. If both of these are squares, then that means we have a right angle right here. So this is my hypotenuse, so 15 squared plus 20 squared equals that diagonal squared. So 225 plus 400 equals that diagonal squared. So y squared equals 625. Take the square root of both sides. So the diagonal is 25 centimeters. That's a tricky one. It's great. Okay, now I'm running out of time. So I probably won't have time to finish everything. So look on the next video for me to explain number 7 and number 8. And then just to go through the rest of the examples on the second page. Okay, so I will talk to you soon. Try these on your own first if you can. Here, set up this right triangle here. You go to the left and then up. So I went to the left 7, I went up y, and this diagonal, or this radius of the circle, is now 25. So go ahead and do the Pythagorean theorem with these three numbers, and we'll check it very soon. Bye.